Introduction to power. What is power and how do you calculate it? Power is the rate at which work is done. As a reminder, work is the amount of energy transferred. The work-energy theorem states that the work is equal to the change in kinetic energy.
Power equation is work over time. We can rewrite this in several different ways. Work over time. Force times displacement over time, and mass times acceleration times displacement over time, with the units being in joules per second or in watts.
In this example, the amount of work done by the cranes is the same. However, the crane on the right lifts the object much faster. This crane exerts more power. Like work, without a change in displacement or a change in energy, you do not have any power.
A machine applies a 60 Newton force for 0.75 meters in 1.5 seconds. The power is the force times the displacement divided by the time, or 60 times 0.75 divided by 1.5, which equals 30 watts.
How much power must a 200 kilograms rocket have if it is to go up 75 meters in 3 seconds? The power is 200 times 10 times the displacement, which is 75 meters, all divided by 3 seconds. The power of the rocket is 50,000 watts. How long does it take a machine with a maximum output of 900 watts to lift upwards a 60 kilograms object 3 meters? Solving for time, we get 60 times 10 times 3 divided by 900. This equals 2 seconds. How much power must the car engine have to accelerate the 700 kilograms car from 0 meters per second to 15 meters per second in 3 seconds? We don't have force or displacement given to us, so it'll be easier to use our work-energy theorem to calculate the change in kinetic energy. Remember that the formula for kinetic energy is half mass times velocity squared.
Solving for kinetic energy, which is 1/2 the mass times the velocity squared, we get 0.5 times 700 times 15 squared, which is 78,750 joules. If we divide by the time of 3 seconds, we get 26,250 watts. Therefore, the car must have at least 26,250 watts to accelerate the car from 0 to 15 meters per second in 3 seconds.
Instantaneous power is slightly different from average power. It's the power being used at a given moment instead of over a long period of time. We can rewrite our power equation to force times displacement over time. Remember that displacement over time is the same thing as velocity. So instantaneous power is force times velocity. Keep in mind this formulation won't work well if we need to consider work of the object as it accelerates. Instantaneous power is the amount of power at any given time. This is different from the average power, which is the total amount of work done over a long period of time. A 70 kilograms man climbs 3 meters up a ladder in 4 seconds. How much power did he have? 70 times 10 times 3 divided by 4 equals 525 watts. A 300 kilograms car is stuck in the mud with a coefficient of friction of 0.4. A tow truck wants to accelerate the car at a rate of 1 meter per second squared for 10 seconds. How much power does the tow truck have? In this problem, we need to account for the force of friction. Friction is going to be 300 times 10 times the coefficient of 0.4. Then we add that to the force necessary to accelerate the car, which is 1 times 300. The net force then is 1,500 newtons. The displacement is given by the equation displacement equals 1/2 times the acceleration times the time squared, which is 0.5 times 1 times 10 squared, or 50 meters. When I add these values to the power equation, I get 7,500 W. Remember, work is the transfer of energy by force along a displacement. Power is the rate at which work is done. Thank you for watching.